Okay, so we're going back to this problem. It's going to be a separation of variables, and it's going to show a slope field. So in your homework, you had some problems with slope fields, and they just wanted you to look at a slope field and match it with what the equation is. So I'm going to kind of just refresh your brain on how those work, because we haven't done very many. So this is asking me to draw a slope field for dy dx equals negative x over y between negative 5 and 5. That doesn't mean it's the only place it exists, but that's how far they want me to draw it. In both directions, x and y directions, and sketch some sample curves and see if I can figure out what the shape of them is, what the solution to the differential equation would look like. Now, not only that, we can actually find the general solution to the differential equation because it is one that we can do by separation of variables and find the particular solution through 0, 2. So we're going to do a lot with this one pretty simple problem. Okay, so what slope fields are actually useful for is for differential equations that you can't solve. So in other words, I know what the derivative looks like, but I cannot solve for the original function. But if I sketch a slope field, I can get a picture for how the original function would behave based on its slope. Okay? These are generally, as far as really useful, only going to be useful if a computer generates them, but it's a concept that we learn and understand. So the ones in your book, the computer generated them for us, and we're trying to identify where it goes, what equation goes with it. So when you see dy dx equals negative x over y, we're going to go ahead and just mark, if you're doing it on this, through the center. If you're not doing it on printed paper, just go 5 in each direction. Okay, so make a center. And you'll want to do it pretty neatly, or it will look, slope fields look pretty gross pretty fast if you don't do them neatly. There's even some graph paper back there somewhere if you really want graph paper. In my cabinet back there. But if you just do it pretty neatly, 5 in every direction. Jake, you're drawing 5 in every direction on your sheet. Okay, so what I'd like to do, basically you substitute in an x and a y, and you figure out what the slope would be at a point, and you try to draw a little tiny line that has that slope at that point. But I don't really want to do it for 100 points, okay, because that would be an awful lot of points to do. So I want to try to figure out some patterns. So one of the things I can do is figure out what would happen if x was 0. Okay, so if x was 0, doesn't matter what y is, dy dx would be what? 0. Okay, it would be 0 over something. So what that means is that if x is 0, then the slope is going to be 0. So that would be all along the y-axis. You would have an x of 0. So I'm just going to draw some little slope field lines. They're going to be kind of hard to see because they're exactly where your lines are. Now it's true for any x is 0, so I could even put them in like right here in between. Any x value of 0, you're going to have a slope of 1. But I'm just going to do it on the whole number of values because I don't want to get ridiculous with how many of these little lines I have. But anytime x is 0, the slope of your original equation is 0. What might be another good thing to put in there? I like it. So if y is 0, what's going to happen to undefined? You'll have division by 0, and undefined is just a vertical line. Okay, and that's going to be, and wouldn't you know it, these are already little vertical lines, so it's kind of annoying, but that's the case. Okay, now really here, and that's a good point, see how I've got it going horizontal? Would it really be horizontal at 0, 0? No, undefined. Okay, so I need to change that. And actually 0 over 0 is an indeterminate form, and means it might not even be a straight up and down line. But we'll figure out why in a second. Okay, so now it just kind of doesn't look all that much different. But again, in order to, you can just substitute in some points, but I'm going to try to get a lot at a time. So I'm going to say, what if y equaled x? What if they were the same thing? Okay, yeah. It'd be like negative x over x. It'd just be negative 1. So that means that anywhere y equals x, like at 1, 1, 2, 2, 3, 3, I'm going to have a slope of negative 1. So let's just say like at 1, 1. Okay, so I'm going to take that point 1, 1, and I'm going to draw I want something that has a slope of -1, so I've pointed my ruler so it's down 1, right 1. And what I'm going to do, though, is just do a little line right there. Okay, so it's through the point 1, 1. I didn't actually connect it all the way to down 1, right 1. I just, and then like at 2, 2. You would tilt your page that way. Now, once you do it, you can tilt every time, but you can also just try to approximate it all along the line y equals x. So at 1, 1, at 2, 2, 3, 3, 4, 4, 5, 5. Also, -1, -1. -2, -2. And you can just approximate once you know the shape, but I'm just kind of that bad at it that it probably is going to look better if I actually use a ruler. Something Tim can appreciate. Alright, so at least I got a bunch of points out of one calculation. Now I'm going to try if y is 2x. So then it would look like -x instead of y, I'd put 2x. So what would the slope be? -1/2. Those x's are just canceling. Okay, and so that's along 2x. Okay, so that's basically you have 0, 0, and you have a slope of 2, so up 2, right 1, so like right here. Okay, or you could think of it as the point 1, 2. Okay, and you want a slope of -1/2, so that's down 1, right 2, and I'm just going to draw that. Once I draw that, if you can approximate that shape, you can just from there go up to right 1 and try to draw the same flatness. All that matters really is that it looks the same flatness as the others. Because I didn't use a ruler, I tried to estimate it. Jake, how are yours looking? Oh, well, you're right. It was right here. You had me. You're right. However, I also don't think you're doing it. Oh, there you go. You're getting a couple. All right. Okay. Good, good. I'm proven wrong.
It looks like a supersonic balloon.
It does kind of look like a supersonic. Okay, so then I got to go down to right 1. And I got to have the same slope. What's the matter?
Aren't you drawing a positive slope?
Yeah, so along the line y equals 2x, I'm drawing little lines that have a slope of -1/2. So along the line y equals 2x, which has a positive slope, I'm drawing little -1/2 lines. So the slope is -1/2, but I'm drawing it along y equals 2x. Okay, so I kind of have some of those. How about y equals -x? What do you think? Just be 1. Okay, so we finally got some positive slopes going along, and that's going to be like, I'm going to put some dots at -x. Okay, so this is what the lines are for -x. Okay, just a slope of -1. Okay, and I need to have positive slope of 1 there. It should look like this. By the way, slope fields are tedious. What do you think? Now, how they would test this is they would probably tell you to draw it at specific points. So they'd say, draw the slope field lines at, and they would list some coordinate pairs for you. So you wouldn't have to draw that many. You have to draw a lot to get an idea of the shape of the curve, which is why it would be nice to tell a computer what you wanted. Okay. I'm going to go for y equals -2x. So that would just be 1/2. Starting to get kind of a look at it. Okay, so that's going to be along -2x. I'm just going to put myself some dots down to right 1 and up to left 1. And these need to be little flat lines. Up 1, 2. All right, have I got any gaps that aren't looking like you wish I had some points there and I don't? And I see kind of empty over here and over here. Okay, let's do that. Okay, so that'd be negative x over 1/2 x. So the x's cancel. What do you get? Yep. Okay, so that I have to do along 1/2 x. So that's up 1, right 2. I'll just make some dots. And down 1, left 2, down 1, left 2. And along there, I need a slope of negative 2. I'm about to be satisfied with this. I don't know about y'all. Yes. If you can tell what it is, we've done enough points. The solution to this is going to be a family of circles. Okay. And the way you kind of tell, it's going to want like the particular solution through 0, 2. So if you draw 0, 2, kind of scared. I was thinking about using a giant marker, but I don't trust myself. Maybe my pink highlighter. I'll commit to an erasable pink highlighter. So if you put a point at 0, 2 to sketch, oh, I'm sorry, my phone is on. Then what you're doing is that's telling you at each point what the slope is. So it's flat right now, but then you're following, it's going a little bit of a curve, and then a steeper curve. It eventually goes negative. Okay, and then it starts to rise back up. It gets steeper. Okay, it's supposed to give you the idea of the shape of the curve.
It looks like a face inside of an apple.
Luke, I've been told it looks like a face inside of an apple. Catherine, that was an update for you as well. All right. Okay. So that's a slope field. It's supposed to give you a picture of what the family of curves looks like, and so we'll look at your homework in a minute, maybe just do that together to try to do the matching for some of the slope fields. But the only thing else I want to do with this problem is solve it, because it is solvable. Okay, so the dy dx equals negative x over y is solvable by separation of variables. So suggestions on what I should do. Okay, works for me. Yes.
How do you know, like when you drew that circle right there, what points did you follow?
Well, I did the 0, 2 that they started with, and basically at 0, 2, we had a horizontal line, so it was supposed to be flat. But if I look to the right, it's like it's supposed to follow what happens as it goes through. So this one was kind of going down, and then as you move to the right, it's getting a little steeper, vertical. It's like a little pointers. It's not all that easy. Sometimes some of them are kind of rough, but this one kind of looks like a concentric circles, so it's a little bit easier than some. Okay, once you have it separated, all you have to do is integrate. So when you integrate y, what are you going to get? And over here. And now a lot of times we solve for y, but because I think this looks like circles, I'm going to get everything on one side. So you have 1/2 x squared plus 1/2 y squared equals c. And I'm actually going to multiply through by 2. So if you multiply through by 2, and if it's just a constant times c, you can let that stay c. And so that is an equation for the family of circles, because the general equation is this. Okay, so c is going to represent your r squared. Now they in particular said not to give them a general one, but to give them the equation through 0, 2. Okay, so if I take this and put in the point 0, 2, then you would have 0 squared plus 2 squared equals c. And then you just have 4 as c, so this is x squared plus y squared equals 4, which is just a circle with center. What? 0, 0, yes. Is that what you said? I just couldn't hear you. And then the radius? No? 2. Radius of 2. Okay. All right. So now let's go to your homework, to the ones that looks like, okay, so this is number 5 on your homework, and it wants you to match the slope field with the differential equation. So we basically have these choices. The easiest way I think to do it is just substitute in some points that you know and see what the slope would be. And then just like kind of go through and eliminate what it might be or what it might be. It's not like I look at one of these and go, oh, it's clearly that one. I don't know unless I substitute in points. Okay, so if you look at this one, I would... Okay. Okay, so tell me your reasoning.
So pretty much, plug in 0, obviously. It's just 0.
Okay. Why? I actually don't think you are.
Because if you go with 1, then it's not -2, it's just 0.
Well, at 1, it's negative. This is 1. Can you see their little 1?
Oh,
So that's their little tiny 1, and you have a slope of -2. I mean, maybe. Like, you can't really tell the scale that great, but you can at least tell it's negative.
that looks like now I think I was...
Yeah, I think you are correct, too. So if you look between these, okay, so, and my board's kind of fuzzy today, I don't know why. So we're thinking that this one is this one.
I thought it was 1.
Oh, I circled the wrong one. I'm sorry. You're right. I just... Sorry. I'm not watching what I'm doing. So dy dx. And the other way you can tell, that's the only equation. What's different algebraically from that equation compared to the rest of them? Yeah, it doesn't have an x, so it's completely dependent on y. So if you look all the way through here, at any given y value, the little subfield lines all look the same. So that was a good one to start with. All right, what do you want to try next? Like, we can pick an equation, plug some things in, and see which one it looks like. So what do you want to try? This one, this one? Let's do one of these. Pick one of those.
I think number 3 is G.
Oh, we got him great. All right, let's check him out. So 0, 0 would be undefined. We definitely got some issues there, but I mean, this one looks like it has issues too. So it's definitely not A. I would agree with you. Between just 0, 0, it looks like that. Okay, now what points are you going to try that's going to distinguish between those?
We should try some
These are negative, and those are like pretty darn steep. Okay, so like an X and Y, that's 1. That's 1, 1, and that's negative. That's 1, 1, and that's positive. So 1, 1.
Just negative 1 is like should be.
Okay, so you think it's which one?
D.
I think so too. Okay, so we think this one. Do y'all see? Are y'all following why, or are you just confused and think I'm scribbling around? You're not going to tell me. Okay, so what we're doing here, we put in 0, 0. We're like, okay, it's undefined. But when we look at this graph, it's undefined all of it 0 also. Okay, but if we picked a point like 1, 1, 1, 1 would come out negative 1. And here that's positive, so this one at 1, 1 is negative. So we picked that one. Alright, so we've taken care of these two, or gonzo. So we got to pick between these two. Which one do you want to try first? Try 4. Okay, so 0, 0 would be the same for both of them, so that's not a very good one. So you either can look at what looks different between these two graphs and try one of those points. What looks weird?
I think 4 should be B.
You think 4 should be B, and you're basing that on the point?
Because I'm just basing off all the quadrants.
One.
Because like the first quadrant is
All positive.
And so that's what should
And this has a... I agree with that. Y'all see what he's saying? He explained it very well. He said...
1, 1, it's for number 4, it should be 3, and it is. It's steep, and for the other one, it looks like it's for 0.
Something pretty flat. It definitely doesn't look steep. So I agree with you. Okay, so in the first quadrant, you said everything should be a positive slope based on this one, and in fact, this is. Okay, so we're feeling pretty good. So by process of elimination, this should be, but we're going to check it out and see if it looks good. Okay. by the way, I do these same examples every year, and I have to sit there and look. It's not like I remember, oh, this looks like that. I have to sit there and try points. It's not just,
We have to like explain this on
no. It says match. It doesn't say explain. Okay, so this is just, you're going to write down the answer. So if we just test 1, 1, at 1, 1, 1 squared minus 1 would be 0. So at 1, 1, it could be flat here. We see this right in that area. You could try a couple more if you want, but I think you have succeeded on this one. Okay. Okay, I'm going to pause this and figure out what on earth Jake's doing back there. He's up to something. He's sick of something. Okay, so just to start for number 10, it does ask you to draw a slope field. So when you sketch a slope field, you're going to have like T on this axis and P on this axis because it's dP dt. And so it's going to be like little slope lines. So if you think P over T, that's like dP dt. Okay, and it tells you for this particular thing that it's the equation for the rate of change of population in thousands for a certain species. So your time is in thousands of years, and then you're going to have your no, it's not. What is your time in? Sorry, the population was in thousands. Did it tell me the time? Oh, then I guess it's just regular years. Okay, so we're just going to put, I'm only doing the first quadrant because we're talking about positive time, and population can't be negative. Okay, so this population I'm just going to put in thousands because you'll need it later in the problem. And they didn't really tell me time, so I'm guessing times in years. So this would be like 1,000, 2,000, 3,000, 4,000, 5,000. Okay, so if I wanted to pick what it was going to be, notice this is only dependent on P. So all I'm going to have to do is put in a P value. And then I can go all the way along that P value, and it's going to be the same thing. So let's just say we do P is 1. And no, let's do that, but maybe we're here. If P is 1, then dP dt would be 5 minus 2, right? You are sure right. Okay, so I need a little slope of 3 anywhere P is 1, so all along here. So I'm going to try to go, there's my little dot, up 3, right 1, so pretty steep. Okay, and you're just going to do that all along. And then I want you to do that, shoot, paper's falling, for 1 through 5 and get a slope field. And the other thing that might be interesting to figure out is where the slope is 0. It may ask you that later in the problem. But I would also like you to solve for where the slope is 0 and make sure that is shown on your slope field. Okay. All right, so that's my hint for that. So you can ask me more questions on 10 next time if you need to. Do you have questions on any of the ones that weren't slope fields? So not 5, 10, or 14, which might not have left much. 12 and 7F.
I can hear 7F.
You can do which one? Okay. So you're doing which one? Okay, here is 7F.
I'll just leave this like right here. Alright, what's up guys? We're going to be doing 7F now on the homework. Yeah. 7F. Yeah. Are you updating that hourly? Alright, so 7F is x dy dx equals x plus y.
They just want to know how I felt about this.
So what you need to do here is you need to get everything onto one.
I don't think that's 7F.
That's 17F. I was about to say I don't really recognize this.
Yeah, 7f is the one with the square root. Square root of x plus 1 dy dx equals x over y. And so what you do from here is you got to get all your x's and all your y's on one side. So I divided the x squared square root over, and so then I got dy over dx equals x over square root of x squared plus 1, and then times y. And so then I just cross multiplied this, so you end up with, or I didn't cross multiply all of it, just the y over, and left this here. So you pretty much are just multiplying that over and multiplying the y over. So you get y dy equals x dx over square root of x squared plus 1. And what you got to do is you got to move this up. So y dy equals x square root, or not square root, it's x squared plus 1 to the negative 1/2, because you can't do an ln because it's not to the power of 1. Found that out yesterday. And then from here you just integrate both sides. So this one is easy. This one's a little trickier because you have to do the derivative of the inside, which is 2x, so you have to multiply times 1/2 on the outside and 2 on the inside. So you end up with 1/2 y squared equals, and then you would add 1 to this exponent. So you would get 1/2, and then you multiply times the reciprocal. So there's 2. But it doesn't really matter because you still have this 1/2 right here. So those are just going to cancel out. And then then you just simplify from here. Oh yeah, let's see. Thank you. And then you can multiply times 2 and just solve for y squared, and then yeah, I'll straighten it out too. Yeah. What, this x right here?
Substitution and then show you.
Oh yeah, the u is,
Now they can see.
That's what you get.
yeah, u equals x squared plus 1, and then the du equals 2x. So you already have the x here, so you have to multiply times this 2 to end up with the derivative. So then from here, going back to the bottom, you just multiply times 2 and you get that 2 again for some reason. And that's it.
Okay, now kind of move it over and down.
And they didn't give you a point to solve, did they?
That's good.
Alright, that should work.
You just hit the stop, so we'll pause for a minute.
Alright.
Alright, so this is number 12. The first thing we're going to do is separate our variables. I'm assuming that you probably got that far, maybe? Got absolutely no comment on that. Did you separate your variables? Okay. So I'm putting all that stuff over there. Okay. And then I'm going to multiply by dx. So it look like this. And then I'm a little bit happy because the dy and the dx are both in the numerator, but they're on the wrong side. So I need to divide both sides by 1 plus x squared and divide both sides by negative 1 minus y squared. So you'd have dy over negative 1 minus y squared equals dx over 1 plus x squared. I'm not enormously wild about the negative y minus y squared. Okay, so I'm going to factor a negative 1 out of that. And when I do, what will that leave me? Mm-hmm. Okay. Now, so I've got the negative 1 factored out. Does it matter which side I have it on? It does not matter which side I have it on, so I'm going to multiply both sides by negative 1, and I'm going to put it on the other side. Because this one is going to turn into this. Well, I need to at least take the negative 1 out. It really doesn't matter if I move it to the other side, but it does matter that I take it out, because when I take it out, it looks like one of my integration rules. Do you know which integration rule it looks like? Arctan. Okay. Are you just going to throw out? It is one of them. Okay, so let's just look, because, by the way, arctan is one of their favorites. Okay. The arc sine has a square root. You tend to not see it quite as much. Arctan is way, way a favorite. So what I have is 1 squared plus y squared. So my a is just 1. So this would be 1 over 1 arctan y over 1 plus c.
Are those the only ones that have like rules like that? Those are the
They only do this because if you remember from the derivative rules, like one of them is only different by a negative sign or something like that. Like if you look over here, the derivative between arc sine and arc cosine, this one has a negative. So they really only felt the need to make a rule for one of them because it's just different by a negative sign. Okay, so this guy over here is arctan y. And this guy over here, I'm just taking the negative out. So again, you're right, it doesn't matter which side I had the negative on. What would this be? Yeah. Anybody get that far? Just wait.
Does that mean that you can take the inverse?
Yeah, I am going to do the inverse tan on both sides. Or actually, I'm going to do the tan because this is already inverse tan. So, but yes, I'm going to do the inverse operation. But they also gave me a point, so I'm going to solve for the point now. Okay, so they gave me 0, negative 1. So I'm going to do the arctan of negative 1 equals negative arctan of 0 plus c. Now I need you to remember that when you try to find the values on the unit circle, it's the angle that has a tangent of negative 1. You are supposed to be looking just... Okay, just here, but they actually define it as between pi over 2 and negative pi over 2 is how we have limited the range. Okay, because we limited the domain of tangent. If you think about the normal tangent graph, okay, it goes like this and repeats. Okay, and so when we did an inverse tan, if it keeps repeating, when you do an inverse, then you had to, it would fail the horizontal line test, so you had to limit the domain between negative pi over 2 and pi over 2. And then when you graph arctan, this is the only graph I told you out of all the arcs that you needed to know what it looks like, because it flattens out at pi over 2 and negative pi over 2, and you need that a lot next year, so it kind of looks like that. But when you do arctan of negative 1, you need to find the right spot, which I think you guys found the right spot, which is like right there. The spot where you have the point square root of 2 over 2, negative square root of 2 over 2. But what point would that be if you describe it as a value between pi over 2 and negative pi over 2? Negative pi over 4. Yes. So you gave me one that's coterminal with negative pi over 4. In other words, it is the same location, but they want you to describe it as between negative pi over 2 and pi over 2. If you did arctan negative 1 on your calculator in radian mode, it would give you the decimal equivalent of this. And if you do it in degree mode, it'll give you negative 45 degrees. Okay. What about the angle whose tangent is 0? 0. Okay, so your constant is just negative pi over 4. So I'm going to have arctan y equals negative arctan x minus pi over 4. And, oh, sorry. And that would be a beautiful answer. But unfortunately for us, they decided to go ahead and solve it for y. but we are going to use what Jake said, which was, hey, you're going to undo arctan, we're going to do that with tan. So it's just the same as inverse tan, another way of writing it. So tan and inverse tan are inverses. Surprisingly enough, that's why they call them that. Okay, so what I'm going to do is take the tangent of both sides. So the tangent of arctan y equals the tangent of all of this stuff, because you're doing it to the whole side. The left-hand side is all fun and games. It's easy. What's the left-hand side? Yeah, that cancels. No problem. This side is different. Okay, it's the tangent of something minus something. So I'm going to go to my formula sheet, and it has one of those things. Yeah, it is like the worst one. Fun ones. Okay, but they don't expect you to memorize them. You just got to find it. Okay, so mine's tangent of something minus something, or you could do it as plus a negative. You care? What do you want? Something minus something? You gotta tell me. Okay. Okay, so tan of, I'm just going to write the formula, A minus B. It's not like it's one I have memorized. Would be tan A plus tan B. Nope, nope. Minus. Over 1 plus tan A, tan B. Make sure I got it right. Minus plus. Okay, so the way I'm getting that is I wanted a minus, so I'm reading the symbol on the bottom. So you read this. If I want the symbol on the bottom here, you read the symbol on the bottom everywhere else. So if that's a minus, that's a minus, that's a plus. Okay. They solved it for y. I'm just telling you, because sometimes they'll ask you to solve it for y. If they didn't, I'd have been told it.
Why do we leave it at, like, why can't we leave this tan?
Because that's gross and it's about to look a lot better. Yeah, I promise it actually is. Okay, so let's see if we can substitute into all that stuff. So we have y equals, on this side now I'm treating, this is my A. It has the negative in it. This is my B. It does not have the negative in it because we chose the rule for A minus B. Okay, so I'm going to have the tangent of A, which would be the tangent of negative arctan x. And then I'm going to have minus the tangent of pi over 4 over 1 plus the tangent of negative arctangent x times the tangent of pi over 4. I'm not done. Did I miss a plus sign? I don't think so. That's 1 plus those two things multiplied. Yes, this is actually negative x. I'm sure there should be a good way to know that, but I don't know what it is. It should be. I think so. Okay, tangent of pi over 4. And then we're going to have 1 plus negative x, same tangent. I think we got it. Yep. Now you can flip the order and stuff like that if you want a different version of it, but that is what it is. Alright, so the first thing I did was I just rewrote it, but I went ahead and said plus a negative because I know that this has to be plus whatever y, and so the negative, if there is one, has to be included in the p of x, and that tends to be a common error for me, so I went ahead and did that. I want to solve for dy dx. Well, I realize you have the first couple of steps. You can still play along. Divide through by 1 plus sine x. Okay, so you have dy dx plus, and I'm just going to write this as negative cosine x over 1 plus sine x y. And what would that equal? Yes. Okay, so in this first step, I have now got it in this form, dy dx plus, this is going to be my p of x, y equals q of x. So the next thing is to find my integrating factor. Just making sure I was recording. So that's going to be e to the integral of p of x dx. So that's e to the integral of all of this stuff. Okay, so you got to figure out how to integrate that. Thoughts? Use substitution. Okay, so what's u?
1 plus sine x.
I know where it went wrong.
Do you?
Cos.
Oh, and that's kind of aggravating because I've got a negative cosine x. So, okay, so let's just move it to the outside. I was going to go negative, negative, but that's the same thing. It's sort of silly. Okay, now it's on the outside. Oof. Okay, so now I have equals e to the negative integral of, that's du over u. So ln, we can go absolute value, or we can know it's going to go away eventually. Oh, sorry, thank you.
That's a very
Oh my. Okay, that is a lot of straight lines. So e to the negative ln absolute value of 1 plus sine x. Ln and absolute value don't go well together.
That's why you make your ln a loop. Yes. Yeah.
Alright, that does look a little better. Alright. Okay, so what do I want to do with that now?
Wait, c equals 3.
Yes.
Yeah, I got it.
Okay. But some of that other stuff sounded a little weird, so...
That too.
Ooh, nice. Okay, so this would be ln of... I'm having to really think about writing this now. Just move it up to be to the negative 1. And that way the e and the ln cancel. So you have your integrating factor, and well, we'll just leave it like that. You can move it to the denominator if you want. Okay, so now I need to multiply both sides of the equation by that. Now I can do it right here, or I can write the whole equation again and multiply both sides by it. Okie dokies. Alright, so this is just the same thing I had. Okay, that's just the same thing, and now I'm multiplying both sides by the integrating factor. Oh, it erased ugly. I hate that. So, okay, so I'm multiplying, I'm going to have to zoom out a little bit, both sides by the integrating factor and integrating.
So on the left side, you just have
On the left side I have y times,
the 1 over 1 plus y times the integrating factor.
yes, which, yes, you're right, David, I could put it in the denominator if I wanted to.
So do you have to keep the absolute value bars? Or
Didn't you say that briefly?
They often drop it, but we're going to see how it goes. So, over here, I still have, so this we just know that after I multiply by the integrating factor and integrate, it will get y times the integrating factor. On this side, I have the integral of what? Okay, so I don't have to worry about the left side anymore. What I have to worry about is the right side. Okay, and so what I'm going to do is FOIL this out. So when I do, what will I get? Yes. And I'm just going to write that like that. Now here's the thing, it's plus, you can integrate those one at a time. None of them are hard except for sine squared x. Like this is easy to integrate, this is easy to integrate. Whenever you see sine squared x or cosine squared x by itself, you're going to have to use a double angle substitution. Okay? So it's kind of up to you if you want me to do it like all together, make the substitution here and combine like terms, or you want me to go ahead and integrate this? Okay, we have a call. Okay, so if we integrate 1, we get x. If we integrate 2 sine x, the 2 comes out. What do you get when you integrate sine?
Negative.
Negative cosine.
Okay, so let's go ahead and change this to a negative. Okay, so then whenever it's just sine squared or cosine squared by itself, you go to your double angle formulas, and you're actually going to cosine 2x. Okay, and if you're just trying to use this one. If you're trying to solve for cosine squared, use this one if you're trying to solve for sine squared. Hopefully you did that on your test. So, cosine 2x is 1 minus 2 sine squared x. I'm going to need some backup paper here in a minute. Okay, so solve that for sine squared. So you would have cosine 2x minus 1 equals negative 2 sine squared x. And then divide through by, or I'm going to multiply both sides by negative 1/2. And it kind of depends. That's what I want to substitute. It just depends if you want me to take the negative 1/2 out and understand that it goes to both when I integrate these separately, or distribute it now so that I see it goes with each one. Okay, that's what I needed to know. Okay, so that's what sine squared x equals. And I'm going to go to another sheet. And I'm just going to substitute in this instead of sine squared and integrate it. So you're actually almost there. I'm going to write it as 2 separate integrals. So I'm going to take out the negative 1/2 and then do cosine 2x. And then I'll just leave that as a half. Does that make sense? Okay, so talk to me about the cosine 2x. I like it. So, I don't know if pink shows up very well. Let's go red. So u would be 2x du, and I need it. So this would become minus 1/4 integral of cosine u du. This is just a half x. What is the integral of cosine? Sine, so this would turn into sine u, but that would be sine 2x. And everything else I'm just writing. Lots of writing. Copying it over. Now you've actually integrated everything. Okay, really all that's left is if I want to combine like terms, if I want to solve for y by dividing both sides by what's by the y, and putting in the point to solve for c. So, the only thing I can really combine is this. So over here, can I multiply both sides by 1 plus sine x at the same time? Yes. Thank you. Okay, so I would have 3/2 x minus 2 cosine x minus 1/4 sine 2x plus c. That is times 1 plus sine x. Okay, because this is like having y over 1 plus sine x, so you're multiplying both sides by it to get it to cancel. And now you just put in your point. What's your point? 0, 1. Okay, so you get 1 equals, this would be 3/2 times 0. What's the cosine of 0? Okay. Minus 1/4 sine of 0.
0.
And then times 1 plus the sine of 0. Okay. So that part doesn't matter. So we get negative 2 plus c times 1 if you want.
C equals 3.
So all we have to do is rewrite that. That's a pretty good problem, don't you think? Can you maybe see why I didn't add it on yesterday?
Yeah, it's very lengthy.
would have been a lot for one day. Okay, and that's it. And you got about 15 minutes to start on the homework. And I'll just write it. You know what it is altogether? I'll just write it. Day 1 was 2, 5, 7, D, F, 10, 12, 14. Day 2, number 16 can be done either way, as the integrating factor way or separation of variables. 17 is actually like A through F, and then 18 and 19.
This is